All right, let's get right down to it. Today, we're talking about the absolute bedrock of reality itself. We're talking about matter and energy, the two fundamental pillars that make up literally everything we see, everything we touch, and everything we experience.
I mean, seriously, just take a second and look around you. Your phone, the chair you're in, even the air you're breathing. What is all this stuff? It seems impossibly complex, but the answer is actually, well, surprisingly simple.
Because believe it or not, everything, and I mean everything, from the tiniest particle to the biggest galaxy, it all works based on just two core ideas: matter and energy. So let's start with the first half of that big duo, matter. Put simply, it's all the physical stuff that exists in our universe.
So here's the classic scientific definition. If something has mass, which is just a way of saying you can measure how much stuff is in it, and it takes up space, then congratulations, it's matter. It sounds basic, but this one rule covers an incredible amount of things.
So, yeah, a solid rock, obviously matter. But what about a tiny drop of water? Yep, that's matter too. And get this, even the air inside a balloon is matter. You can't see it, but it has mass and it is definitely taking up space.
Okay, but this is where it gets really cool. What if we could zoom in? I mean, way, way in, past anything our eyes can see. What would we find at the very heart of that rock, or that water, or even the air?
The answer is atoms. These are the fundamental building blocks of all matter. You can think of them like the ultimate Lego brick of the universe. They're the smallest possible piece of an element, like gold or oxygen, that still acts like that element.
But wait, there's more. An atom itself is made of even tinier things. Right in the middle, you've got this super dense core called the nucleus, which is packed with protons and neutrons. And then, buzzing all around it, is this cloud of electrons.
Now this is the part that is just going to blow your mind. The scale here is unbelievable. All the solid stuff you see around you, at the atomic level, it is almost entirely empty space. If an atom were the size of a giant sports stadium, the nucleus would be like a single pea sitting on the 50-yard line. The electrons would be like little specks of dust flying around in the nosebleed seats. Everything you think of as solid is mostly nothing.
Okay, quick sidebar here, but this is really important. We tend to use the words mass and weight like they're the same thing, but they're totally different. Your mass is how much stuff you're made of, and that number doesn't change whether you're on Earth or Mars. Your weight, on the other hand, is just the force of gravity pulling on that mass. That's why you'd weigh less on the moon.
So, we know what matter is. But how does it behave? Because it's not always the same, right? It can exist in totally different forms or states, all depending on what's going on around it.
And what's the magic ingredient that controls which state matter is in? You guessed it. It's energy. Think of energy as the volume dial for matter. The more you turn it up, the more excited and active the particles get. Let's just use water as an example. When it's a solid ice, its little particles are locked into a tight grid, just kind of vibrating in place. Now add some energy, heat it up, and it melts into a liquid. Now the particles can slide around and flow. Add a whole lot more energy, and it turns into a gas, steam, with particles just flying all over the place. And if you crank that energy dial up to an insane level, you get plasma, a superheated gas where atoms get torn apart. That's what stars and lightning are made of. It's actually the most common state of matter in the whole universe.
All right, so we've got a good handle on the stuff. Now let's talk about the mover. What exactly is this energy that's making everything happen?
So, unlike matter, you can't hold energy in your hand. It's not a thing. It's the ability to make things happen. It's what moves things, heats things up, and makes change possible.
And this brings us to one of the most important rules in all of physics, the law of conservation of energy. It basically says you can't make energy out of nothing, and you can't get rid of it. You can only change it from one form to another. So when you burn a log, the chemical energy inside it doesn't disappear. It just turns into heat and light. The total amount of energy never changes.
Now, energy comes in a ton of different flavors, but you can boil most of them down to two main types: kinetic and potential. Kinetic energy is the energy of motion. Think of a ball rolling down a hill. Potential energy is stored energy, energy that's just waiting to be used, like that same ball sitting at the very top of the hill.
Okay, so we have matter, the stuff, and energy, the ability to make stuff happen. But how does that actually work? How does energy actually get matter to do anything? The missing link here is forces.
A force is really simple at its core. It's just a push or a pull.
That's it. It's the way energy is transferred to an object to make it speed up, slow down, or change direction. And you are surrounded by these forces every single moment. Gravity is the force pulling you down into your chair. Friction is the force that stops a rolling ball. And the incredibly powerful force of electromagnetism is what holds your atoms together and makes your computer work.
All right, let's bring it all home now. We've got the stuff, and we've got the mover of the stuff. This partnership, this dance, is what runs the entire universe.
I love this quote because it sums it up perfectly. Matter gives the universe its substance, it's the stage, and all the actors. But it's energy that drives all the action, all the change, all the dynamics. You really can't have one without the other. They are two sides of the very same cosmic coin, locked together in this grand dance that shapes everything we see and everything we are. And all of this leaves us with one last, massive, brain-melting question. If energy can't be created or destroyed, and the total amount in the universe has always been the same, then where did it all come from to begin with? It's a question that takes us to the very edge of what we know and right back to the beginning of time itself. Something to think about. Thanks for tuning in.